Welcome to another physics class. Today, we want to continue from where we stopped in our last lesson. During our last lesson, I promised that in the next class, we are going to continue with a sample under coefficients of friction in an inclined plane. So, for today, we want to continue to example 3. And the question says, a body of mass 4.5 kg slide down a plane inclined at angle 50 degrees to the horizontal. Calculate the 1. Acceleration of the body. 2. Normal reaction force. For you to understand this topic, you need to go back and watch our last video on the topic, coefficients of friction in an inclined plane. If you are just joining us, please don't forget to like, share, and subscribe. So when I have a new video like this, you'll be able to get the notification in time. So solution. According to the question, the first thing is to draw the inclined plane. Let's say this is the body. The question says the mass of this body is 4.5 kg. And the angle of inclination, according to the question, is 50 degrees. So from this one now, we have to calculate the acceleration of the body. But the question says, take g is equal to 10 meters per second square. If that is the case, to calculate the acceleration of the body now, don't forget, for this body, according to the question, to slide down, the horizontal constant force to slide down the body, as we explained in our last lesson, F is equal to W sine theta. If the bodies need to accelerate, force to accelerate we equal to F is equal to MA. And from there now, take this one as equation 1, take this one as equation 2. This is horizontal constant force that will slide down the body, and this is the force that we are accelerating. So both are force. Then equate 1 to 2. So we are going to have MA is equal to W sine theta. Don't forget, the W is the weight of this object, which also we have downward. And note, or but, W is equal to mg. So we can now have MA is equal to mg sine theta. So M will cancel M. So we have A equal to G sine theta. So from the question give us 10 multiplied by sine 50. And sine 50 will now give us, now sine 50 will be equal to 10 multiplied by 0.766. And the A that we are looking for will now be equal to 7.66 meter per second square. That is the value of acceleration of the body when it's sliding down the plane. Now, for question number 2, normal reaction force. And don't forget, as I said in our last lesson, the normal reaction force is also called perpendicular force. So to calculate this one, and this one is denoted by capital R. And don't forget, our R will be equal to W cos theta. All these formulas have been derived in our last lesson. So W, as I said, is equal to mg cos theta. So therefore, m is given as 4.5. That is 4.5 multiplied by 10 multiplied by cos 50. And this one will now give us 45 cos 50. This one will now give us 45 multiplied by 0.642. And the final answer for R will now be equal to 28.89 Newton. That's the value of R. Now let's take this one as example 4. A body of mass 40 kg makes an angle of 60 degrees to the horizontal if the coefficient of friction between the body and the plane is 0.6. Calculate the magnitude of the least force needed to keep it stationary on the plane. Now let's put it into draw so that we know the direction to follow. Let's say this is the body. The mass, according to the question, is 40 kg. Now, if the body is to keep stationary and the angle is 60 degrees, then the horizontal constant force, F, will act along this direction. Then, the force that we need to keep it stationary, we move to this apart. Therefore, the frictional force will act in opposite direction of this one. So if we have our FR, we have like this. The body to not slide down. This is the force that will slide it down. Then this one will be opposite to it. So to keep it stationary, another force must be applied along this direction. So if this is the case now, from what is on the board now, then to keep this body stationary, it means the force needed will be equal to the horizontal constant force minus the frictional force. So we have P will be equal to F minus FR. So for the body to be stationary. So if that is the case now, and don't forget our P now will be equal to W sin theta, that's the magnitude of the horizontal constant force. Then for the frictional force, that one will now give us mu R. That is, the coefficient of friction is given. So also, don't forget, our R is normal reaction, but R also is equal to W cos theta. If that is the case, the least force that needed will now be equal to W sin theta minus mu into W cos theta. So from there now, and the mass of the body is given, it means, don't forget, our G is always constant. That's 10 meters per second squared. It is given in the question. So if that is the case now you can now see also our W is equal to mg. So we can now see P will be equal to mg sin theta minus mu mg cos theta. So this one, the mass of the body is 40. That will be 40 multiplied by 10 sin 60 minus 0.6 multiplied by 10, multiplied by 40, multiplied by 10 cos 60 degree. And from there now, you can now say this one will now be equal to 400 multiplied by sin 60 is 0.8cc. That is 0.8cc minus 0.6 multiplied by 40 multiplied by 10. That will be 0.6 multiplied by 400. Cos 60 will be 0.5 multiplied by 0.5. So multiply this one and subtract it from this one. Now, our P now, which is the least force, need to keep the body stationary equal to 346.4 minus 120. And this one will now give us P now is equal to, the final answer for P will now be equal to 226.4 Newton. That is the least force that we require to keep the body stationary on the plane. Now let's take this one as example 5. The body of mass 2 kg is placed on a rough inclined plane at an angle 30 degrees to the horizontal. Calculate the 1. Resultant force acting downward the plane. 2. Acceleration of the body if the frictional force of 5 Newton acts between the body and the plane. Let's, the first thing to do again, to draw it and know the direction of the force acting on the body. This is the inclined plane. The angle of inclination according to the question is 30 degrees. So let's say this is the body, and the mass of the body is 2 kg. Therefore, from this one, we can now say that the force, the horizontal constant force acting along this line, F, if that is the frictional force we act in the opposite direction, that is Fr, then the force acting downward, the plane, also the force we act along this direction, that is F, or let's call it P to differentiate. So to put this one into equation also, since both F and Fr are in opposite direction, so we are going to have P equal to F minus Fr. That would be the best equation to solve this one. This one are in opposite direction, so this one, the total horizontal force. So this one will now give us total horizontal force. Don't forget the magnitude of this, our horizontal F, is W sin theta. Then the frictional force is given, that is minus 5. So we are going to have mg sin theta minus r. That will be m is 2, then g is 10. That's multiplied by sin 30 minus 5. This one will now give us 20 multiplied by 0.5 minus 5. So this one will now give us 10 minus 5. So the force needed will be equal to 5 Newton. Question number 2. To calculate the acceleration of the body, which will be equal to P, will equal to F, is equal to ma. And we calculated our F as 5 Newton. That will then our A now will equal to P over, That is, from the P is equal to F, as I said the other time, is equal to MA. So our A will be equal to P over M. Then that one will now give us our 5 over 2. So the answer of A now will now give us 2.5 meter per second square. Let's take this one as example 6. The question says, calculate the force parallel to the slope or plane to move up a body of mass 2 kg, inclined at angle 30 degrees to the horizontal with an acceleration of 2 meters per second square if the frictional force is 10 Newton. G is given as 10 meters per second square. As I said, the first thing to do is to draw the diagram so we know the direction of the forces act on the body. Incline at angle 30 degrees to the horizontal. Let's say this is the body. The mass of the body, according to the question, is 2 kg. So this body is moving up now. Let's say the force that we need to move it up is P. Now, since this thing is moving up, the frictional force will act in the opposite direction. That is the Fr. Don't forget our parallel force, which is constant. We always act like this. So from this one now, to put this one into equation now, this one will now be the horizontal, the total horizontal force now. Total horizontal force will now be equal to P minus this one and this one in the same direction. That will be F plus Fr. And the acceleration is given as this one. That one will be equal to ma. That will be total horizontal force or total resultant force. And what do we need? We need force P, where P is equal to force needed to move up the body. So if that is the case now, we can now see P now will now be equal to, transfer all this down to this side. So we are going to have Ma plus F plus Fr. So from there now, our F, according to the question, is given. That is 2 kg. That one will now be 2 multiplied by 2. That is the acceleration, plus the value of this, the magnitude of this one is, don't forget, is W sine theta. Then plus this one will be given as 10 Newton plus 10. So this one will now give us 4 plus our W, don't forget, is mg. That's 2 multiplied by 10 mg sine theta plus 10. So this one will be 4 plus 2 multiplied by 10. Angle of inclination is 30 degrees. So that's sine 30 degrees plus 10. So the force needed will now be equal to 4 plus, this is 20 multiplied by 0.5. That will be 10. 20 multiplied by sine 30 is 0.5. That will be 10 plus 10. So the force needed to move up this body will now be equal to 24 Newton. Now let's take this one as example 7. A bus of mass 50 kg slides down a smooth plane inclined at 15 degrees to the level ground. Calculate the 1. Acceleration of the bus. 2. Force needed to stop the bus from sliding down the plane. 3. Force needed to push the bus up the plane with acceleration of 0.5 meter per second square. G is equal to 10 meter per second square, assuming the plane is a frictionless plane. Now, the first thing is to draw the diagram and show the direction of all the forces on the bus. The angle is 15 degrees to the horizontal level. Let's say this is the bus. The mass is 50 kg. Now, the fourth question says we should calculate the acceleration of the bus. As I said the other time, to calculate the acceleration, the horizontal force, F, is given as W sine theta, and the force that will accelerate the body, F, is equal to ma. Call this one equation 1, call this one equation 2, equate the two together. Then you have ma is equal to W sine theta, and ma will be equal to mg, since W is mg, sine theta. M will cancel m, then A now will be equal to G sine theta. Our G is given as 10 meter per second square, so that will be 10 sine 15 degree. So that will be A now will be equal to 10 multiplied by, that is 0.258, and A will be equal to 2.58 meter per second square. That is the acceleration of the bus. Second question says force needed to stop the bus from sliding down the plane. Let's say this is force that we need, call it P. And from there now, since the question says it's a frictionless plane, so our Fr will be equal to 0. So question number 2 now. Force needed to stop the bus from sliding down the plane. So that is supposed to be P be equal to F minus Fr. But mind you, according to the question, Fr is equal to 0. So we have P is equal to F, which is equal to W sine theta. So that will be, our P now will be equal to mg sine theta. That will be the mass of the body, according to the question, 50 multiplied by 10 multiplied by sine 15. And sine 15, as we said the other time, is 0.258. That will be 500 multiplied by 0.258. P now will be equal to 129 Newton. That's the value of the force needed to stop the bus from sliding down the plane. Now the last question says force needed to push the bus up the plane with the acceleration of 0.5 meter per second square. So it means our Fr will be in this direction. To write the equation for this one, then we are going to have our P will be equal to minus F plus Fr is equal to MA. So our P now, that the force needed to pull it up, be equal to MA plus F plus Fr. And mind you, the question says it's a frictionless plane. So our FR will be equal to 0. So we have P now will be equal to MA plus F. And F is what? W sine theta. That is MA plus W sine theta. So from there, we can now have our M is 50 multiplied by the acceleration given, 0.5. 0.5 plus, that's we calculated our W sine theta the other time as 129. That is 50 multiplied by, or let's write it, that is mg sine theta. So this one will now give us 50 multiplied by 0.5 plus the mass of the body, that's 50 multiplied by 10 sine 15. So this one will be 50 multiplied by 0.5. P now will be equal to, will be, as I said, 25 plus 129. So finally, P now will be equal to 154 Newton. Now let's take this one at question number example 8. A body is released from rest at the top of a plane. The plane, it climbs at 30 degrees to the horizontal, and the height of the plane is 4.0 meter. Then the coefficient of friction is 0.3. Calculate the time the body takes to reach the bottom of the plane. G is equal to 10 meters per second square. Solution. Let's put it into draw so that we can understand it better. This is the inclined plane. The angle of inclination according to the question is 30 degrees. Let's say this is the body. But the question says the body is released from the top of this plane. Release, let's say this is top of the plane. Release from the top of the plane. So you have our F, and since it is being released from the top of the plane, then the frictional force will act in this direction, Fr, and the mass of the body is not given. So then we are now have to calculate the time taken for this body to reach the bottom of this plane. Now, from what we've drawn on the board now, the total resultant force, total resultant or horizontal force, then will now give us, let's say P will be equal to this one, that will be F minus Fr. Now, according to the question, the body is accelerate, then equal to ma. See that is where F is equal to W sine theta, and weight of the body is not given. Therefore, our F will be equal to mg sine theta. At the same time, our frictional force is equal to mu r. Mind you, mu is given, coefficient of friction is given, but normal reaction is not given. Don't forget the magnitude of normal reaction. That would be mu into W cos theta, because our normal reaction is W cos theta. So we can now have our mu now mg cos theta. Now, put in all this one, so our F is mg sin theta. That will be mg sin theta minus mu mg cos theta equal to ma. Now, if you look at this equation, m is common and g also is common. So from there, we can now say that m into mg into sin theta minus mu cos theta is equal to ma. Here now, m will cancel m. So we have g into sin theta minus mu cos theta is equal to a. Now to get the value for a now, we can now say in the reverse way that a is equal to g into sin theta minus mu cos theta. So according to the question, g is 10. Then our angle of inclination, according to the question, is 30 degrees. That is 0.5. That is sin 30 degree is equal minus 0.3 for mu cos 30 degree. So this one will now give us 10 into 0.5 minus, that is 0.3 multiplied by 0.866. 0.3 multiplied by 0.866. This one will now give us 10 into 0.5 minus 0.259. So that will be 0.5 minus 0.259. Now we equal to 10 multiplied by 0.241. And our A now be equal to 2.41 meter per second square. That is acceleration of the body. Now, for the question silent about A, the question asks us to calculate time taken for the body to slide down when it is being released from the top of this plane to the bottom. So if that is the case, but remember that our A, which is acceleration, is equal to v minus u over t. That is from linear motion. From linear motion. Now, if that is the case, mind you, the question says is relieved from rest. If it is relieved from rest, then u will be equal to 0. That is the initial velocity. Then we are now left with v. So we can now say our A released from rest. So if that is the case, our A now becomes A is equal to V over T, which is time that we need. So we can now say that our V now will be equal to AT. And sorry, we need T. Make T the subject of the formula. AT will be equal to V. So T now is equal to V over A. But again, you can now say that V over A, and we don't need V, we don't need velocity of this body. So we can now say that but V is equal to displacement or distance over time taken. So from there, we can now remove this one and say our T will be equal to displacement over time taken, then divided by A. So this one will now give us T is equal to D over T multiplied by 1 over A. So we are going to have T is equal to D over AT. We still have T here, so we can now cross multiply. That will be AT square is equal to D. So our T square now be equal to D over A. Then to calculate D now, because the D is not given, that is the distance of the body to move from the top of this place to the bottom. Now, let's redraw and show our D. From here to here is 4 meters. Now, this place is 30 degrees. Now, from here to here is our D. That is, it moved from this place to this place. That's the distance. Now, to find our D now, that is opposite over hypotenuse. That will be sine 30 is equal to 4 over D. Therefore, D sine 30 degree will be equal to 4. D now will be equal to 4 over sine 30. And don't forget our sine 30 is what? 0.5. So D now is equal to 4 divided by 0.5. And 4 divided by 0.5 will give us, this one will now give for our distance from the top of the plane to the bottom be equal to 8 meters. So come back here now. From T square is equal to D over A, because the question says we should calculate T. So we can now have our T square is equal to 8 over 2.41. So T now is equal to square root of 8 over 2.41. 8 over 2.41 will give us, therefore this one will now give us 3.319, and the square root of this one will give us 1.82 seconds. That's the time taken for the bus, for the body to release from the top of this plane to the bottom. This is convenient point to stop on this topic, that is coefficients of friction in an inclined plane. We done 8 examples now. Done 2 before plus another is making 8. And you still have questions, you can ask your question from the WhatsApp link under the channel. And mind you, if you just joining us today, don't forget to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification in time. Thank you.